Hey, I got a really good one for you today. We're gonna build some hubs for a racing tractor. Now, these we just picked up off of Facebook Marketplace. We got a heck of a deal on it. Someone is upgrading to the aluminum chrome rims for their golf cart. But our problem is we don't have the right hubs for it. But this is where I come in.
Now that we have the plates cut out, our next step is to figure out how we're going to hook it to the shaft. But first, we're going to have to cut these two parts apart. Now, the reason why I decided to cut these plates together was I basically wouldn't have to do two starts when I'm cutting with the cord. While I got the grinder out, I better make sure I take that little tabby off because I don't want to swing it around and break my carbide later in the lathe. So here's the hack of the day. I do my best to cover all of the machines in my shop, moving blankets, before I do any torching or grinding or anything like that, because it's going to keep the dust off the ways and make my machines last so much longer. I'm just going to do my early morning pre-flight check, so to speak, and clean up a bit of the ways and do any oiling that I need to do. And then we're going to reverse these jaws. Originally, when I first got into machining, I had to switch out the jaws back and forth. And then when I got this chuck, I was actually a little bit skeptical on how accurate it was going to be. Now, this chuck isn't super top of the line, but it is a good quality chuck that served me quite well for the last 3 or 4 years. The key is, like anything in machining, I just have to make sure everything's super clean before I take it apart and before I put it back together, or I'll have some burrs underneath that are going to throw my work out and give me a lot of frustration down the road. I'm pretty sure at any level everyone's experienced what I'm talking about. So now that we got the jaws reversed, I'm going to throw this part in here. Now, I've also got to be very careful. I don't have any like grossly large bumps on any side. Remember that tab that I cut off? We just want to make sure that's not sitting on one of the jaws. And it's on the outside if we do have one. I mean, this thing is pretty jagged. The other thing I'm going to make sure here is you can't see it, but there's a little bit of daylight in between the jaws there. So I'm just going to give it a light tap with this lead hammer. Remember that video where I made the lead hammer? That was a pretty good video. You should check that one out after this one.
The thing here is in my setup, I just got to remember that I got to build a hub that's going to make a hole right here, right? So with the setup, I want to make sure that I can actually clear in there and I don't mess up my jaws. So I know I got about that much room. So whenever I bore through, we just got to watch it.
So the first step, like any step, as you always know, is we're going to start with the center drill. The center drill I'm running here is probably a little bit small for this job. At some point, I'm probably going to have to build an arbor specifically just for center drilling, but that'll be another video for another day. I'd hate to get sidetracked like Inherent's Machinery. And if you haven't seen his channel, you should check it out. I'll throw it in the links down below. Also, on that note as well, the cost of admission is a like and subscribe. So don't forget to hit the like button and subscribe so you can get all my latest videos. So the next step here is to make sure that we got the right speeds, because we're going to kind of transition through bigger drill bits. I think I'm running about 400 RPM right now. And the key here is you know, we could get really bogged down with the textbook stuff, but if you notice there, we got kind of white chips coming out of there, and they're looking really, really nice. They're not too hot, we don't hear it squealing, so that's telling me we got a really good speed. Let's turn this off here and have a look at the chips. The first chips coming off here are really nice spirals, and they're white. But as I'm cutting to the end, this is normal to have a gold chip come out because it's kind of pushing a little bit more pressure on the edges and heating everything up, and it can't be taken away by the rest of the material. Next step here is, I'm pretty sure I slowed this down to about 250, 300 RPM. And once again, it's kicking out really good chips. Also, I'm pretty sure some of the experienced machinists by now have noticed that I have a socket on this because I have a Morris Taper 4 drill bit. Yes, this is the drill bit that I found at the scrapyard, and I didn't even need to sharpen it. But the problem was I needed a socket. Now let's measure the shafting. The shafting is 2 inches, but I don't want to cut the hole to 2 inches because I want a shoulder on this. And the shaft size for the spindle will be 1 inch, so the 1.5 inch drill bit is going to be a little bit too small. So we're going to have to get a boring bar and bore out that hole a little bit bigger. I'm pretty sure 1 3/4 will give us enough material on both sides. That way, when we put the set screw in a little bit later, it'll have enough material to maybe put 2 set screws. We'll put them 90 degrees apart, and then we'll also leave enough room that we can put a locking set screw in, because we don't want these wheels coming off mid-race or on a practice run. And unfortunately, we're not putting the set screws in on this video because I'm basically quickly making this hub, and we're running it over to Theron's, and we're going to dry fit it and figure out exactly where we want the set screws and how we're going to do that. There's still a lot of mocking up that we're doing, and we've actually got the tractor ripped completely apart because this year we're going to lower it and we're going to put a little more horsepower to it, and we're going to bring home some wins. So in these videos, using the boring bar in the lathe and the mill machine, I've had a lot of success getting my sizes. However, I think I'm going to have to do some research into getting better boring bars. Cheap boring bars are kind of becoming a bit of a frustration for me, and I almost need a variety of sizes to get on size. Now, although this cheap boring bar does do its job, and I can sharpen the bits, it's just not working and pleasing me too much. I'm getting a bit of a squeal in there, and just a mild chatter. I mean, the chatter's not enough to be really worried about, but it is slightly visible, and it could affect sizes on high precision work. So now that we have the size that I'm happy with, and it's just an arbitrary size that I've just kind of pulled out of thin air. Really, as long as I have 5 thou interference when I do the heat shrinking, it doesn't really matter. And the precision part's going to come in on the outside. This is generally where, if I have an option, I like to do my precision work, because if I'm out by like half a thou or a thou, I can usually sand it. Now, it's just a matter of setting our feeds and speeds, turning the tool bit, and facing this part off. Now would also be a good time to talk to you about my metal selection. Now, this metal that I'm running here, they're basically offcuts from other big jobs. And as you guys know, I'm a bit of a scrap hound. And the key is to knowing what your materials are. The steel that I'm using today is 1045 steel. And the plate, I'm pretty sure, is some kind of QT 400 or 100. I'm not exactly sure, but it's going to work out quite well for the job. It's got a lot of good carbon in it and a good structure to it. I mean, not that we're making space shuttle wheels, but at least we know that we're running really good quality metal. And when you look at some of the other race tractors and see what guys are getting away with and still winning, I'm pretty sure we're going to be good. The next step here is we're going to have to figure out how far we're going to have to cut into it. So we're going to zero off the face. We got to go in that 1/2 inch. And this is where I have to kind of slow myself down a little bit and, not try to like take a lot of material off and overshoot my size. Even though if I did that right now, it wouldn't be a big deal because this is scrap and I've got a whole drawer full of this stuff. I love easy machining jobs like this. They are super fun, and especially when there's no pressure to get it done, like a race tractor, it's really enjoyable, and you can get out there and just kind of relax in the shop and enjoy the process. Now, I know someone's going to be saying I got to use a micrometer and, measure the outside properly and measure the inside with a telescoping. But really, I mean, this is an interference fit, and as long as I get between, I haven't looked it up in the book, but I'm thinking 5 and 8 thou to sweat fit something on. And I do know 10 thou is too much. I know this because I kind of experimented when I messed up, and we'll get to that in a bit. But you know what? 10 tons in the 45-ton press solved that problem. No problem at all. So now that we got the precision part of this made, and we're happy with it, we're going to spin this around. And we're going to use the old ruler between the chuck method. This is going to get me probably within 10 or 15 thou. More than good for what we need. And then I'm going to zero my parting tool in the digital readout. And the next time I spin this around and cut the next one out, it's going to be pretty darn close to the same as this one. So, for the cost of this parting tool, and being the fact that I've sharpened it like a zillion times, with the insert that is, it's got one small flaw, and you've seen this in some other videos when I'm parting off 2-inch steel. That's right, the shoulder will rub on it. But we have a quick solution for that, and it's probably not the one that you're expecting. Normally you'd probably see someone turn it all the way down, but I've got it in my head today with drilling, and basically what we're going to do is we're just going to drill this bad boy to size. Well, maybe not drill it to size, but we're going to drill the plug out, and then hopefully the end part will fall off. Let's have a look and see how it works out. I think it's about time that I get on the old internet and do some more research and get tooled up just a little bit more. All of the improvements in a shop are going to happen in little micro increments. So I think this micro increment, I'm going to do some research, and we're not going to have this happen again. Although, this did work out quite well. I bet you that's going to turn into a really good washer, so I'll throw that in the scrap bin and probably use it later on down the road. So now that we got that done and faced off, let's grab these parts, have a quick look at them, and then we'll head out to the side shop.
Welcome to the Winter Wonderland. We're out at the side shop here where the 45-ton press is. And I've got the turkey burner set up outside here. I didn't want to set it up inside because I didn't want to carbon monoxide myself. We're basically going to throw these on here, heat them up to 300-400 degrees. We'll throw these in the snow to shrink these, and then we're going to press this all together.
So let's take a little side note while we're waiting to heat this up. Now, you'll notice that the roller's down there to the left and the rebar that I'm standing on, probably the compressor motor you'll see here in a couple seconds. Now, you can't build stuff without stuff. And my wife's always on me. She says, "What are you doing with all that crap?" And I've pretty much convinced her that it's yard art. It's called modern industrial, and I think she's almost buying it. However, on another note, you'll probably notice that I'm not in the kitchen heating this stuff up, and I'm outside, so perhaps she's on to me about this. Either way, let's grab the parts, let's take it out to the side shop, and let's see this fit together. Right. Now, remember, these two parts wouldn't fit together before when they were the same temperature. And this is pretty cool science that we have here. It just plops right in there. Mind-blowing. The only thing is, there's a little burr hanging it up, and it didn't go all the way in. So I'm just going to monkey with it here and burn my hand. Don't worry, not too bad. And we're just going to lift it up a little bit, and I had just enough time that it seated down in there. And we'll see in a second here how well this fit worked. Now, it wasn't exactly super necessary to do this, but I wanted to shrink fit this on here and then weld it to make sure that this wheel hub didn't come off, just to be extra safe. Now, remember I said it didn't fit together. I'm just going to kind of prove it to you here. Let's do that again, but since these parts are exactly the same size, I don't think I'm going to need the press, so I'm just going to fit this one together right in spot where it is. This is a relatively new skill to me, and it's actually really fun experimenting with this. Now, that fit together really, really well, and that is not coming off of there. That would have taken tons and tons and tons of force to seize that together, and then it would have bound and maybe gone on crooked. And speaking of that, let's weld this on here just to be absolutely sure. I mean, this is one of my friend's lives that's at stake here, and he's going to be racing this cart, so we want to make sure this bad boy is on there and not coming off. Now, a welding positioner wasn't exactly absolutely necessary for this, but it's going to give me a really nice weld finish on there and consistent. And it's not shown in the video here, but I'm actually going to take two really good passes on it. The first one I'm just going to get in deep into the V groove, and then the second one I'm going to put a nice layer over top just to kind of fill it, much like you're seeing here. The only thing left now is to take it over to the shop, put it in the lathe, and start machining it. Now, you'll notice that I have the pliers on there, and it's still hot. I'm not going to do any precision machining. I'm just going to clean up a few of the spaces while it's still hot, because science, as you might have expected, once things cool down, their sizes are going to change, and it could create a lot of disappointment. I would say the temperature of this part right now is still probably above boiling. Not enough to wreck the lathe jaws or anything like that. Enough to burn my hand though. So what we're going to do here is we're just going to rough face up these parts. And you'll notice that I did a weld on the outside. The weld on the outside really was a waste of time for two reasons. The first reason is I didn't really get that deep in there because I didn't create a fillet. And the second reason is pretty obvious. I mean, I'm machining this off and it's it's kind of disappearing and it's not there anymore. I would have to say this is probably one of the other highlights of the video, aside from the heat shrinking and the broaching that's coming at the end of the video. Seeing the two parts that have been fused together and machining them to be exactly one part and a precision part at that. So let's take a little side note here to talk about something for the novices out there, and it's feeds and speeds. Now, feeds and speeds are really important for a few reasons. Obviously, one of them is going to be surface finish and metal removal and tool wear. However, one of the ones that's least thought of is the type of chips that are coming off. You see the rat's nest is kind of building up here. So someone who's new to machining might be very tempted to reach in there and grab that and pull it away from there. Extreme caution needs to be used, and I highly don't recommend. I'm going to pull this off the face here in a second and do this. And I highly recommend that if you're gonna do something like that, the machine's off at least when you do it, so that you don't run the risk of getting your fingers cut or caught in the lathe. So the next step here is we're going to cut the outside of this hub. And if you look, the tool bit isn't actually cutting on the lead nose. I'm actually cutting on the outside of it, and I'm just taking slow cuts on it. It was a lot sharper here, and the tool bit was kind of wearing, and I wanted to get the most out of the tool bit. And now we got the outside cut, and we're happy with that. We're going to drill the inside of this. Now, by now, this part is actually cool enough that I can put my hand on it, which tells me that I'm not overly too worried about drilling and cutting it. And before I do any precision sizes, I'm actually going to let it cool down to room temperature, and then I'll do the reaming at that point. So now that we're done center drilling this, we're going to grab a 15/16 drill bit, and we're going to jam that through there. Then, which I'm really sorry, I didn't show this in there. I actually bored that to size before I reamed it, and I reamed it to 5 thou under size. And this also leads me to kind of a little side note, is if you're ever going to ream something, it's really important, if the reamer's new to you and you don't know how the reamer works, is to actually give that reamer a check in some scrap material. And for some, it might seem like a waste of time, but it might save you a lot of heartache and a lot of problems down the road. And the formula for reaming is half the speed, twice the feed. So for a 1-inch hole, you'll go twice the feed that you would reaming on a drill bit, and half the speed for your RPMs. I'm probably running a little bit hot here, and I'm sure as you noticed that went in there, that reamer's a little bit bent. And for the experienced machinists out there that have bought stuff from auctions, know exactly my heartache that I'm about to experience here. But I don't want to tip my hand too much. And as I'm pretty sure every single shop guy, machinist, mechanic, millwright, anybody, even the welders, have experienced the same thing that I'm experiencing. Mistakes happen. Now, what makes the tradesman is how you fix your mistakes. I mean, it's actually something I teach my kids. If you fix it better than when you broke it, you didn't break it at all. And we turned out a really good part in the end. One little side note here as well is you'll notice the little trick that I'm doing here. This potentially could be dangerous, but it works quite well so that doesn't spin off into the chip tray. Now, the position that it was at, it very easily could have fell down into the chip tray and then the chuck hit it, and it would have been all kinds of ricocheting bad news. So we're going to speed the whole process up here and get back on track. Now, I bored this out here, and remember that part that I pressed in there, heat shrink? It was pretty well in there, even after I knocked that weld off. And then what we're going to do here is, we're just going to speed this all up. We're going to skim through the whole process that you guys just saw. Well, because you guys know how it happens. But the difference being here is I'm actually going to bore that to size. And bore to size, I did. This is a super precision fit that I am very, very happy with. And you could tell if that was loose, because this running with that loose bar in there at that speed would be wobbling all over the place.
Okay, let's take it over to the milling machine here, and let's drill the holes for the hubs and the screws. I've got the box of screws here, or studs I should call them, and we just got to measure off to the side here. But before we do that, let's talk about quick how a couple different ways we can do this. One way we can do this is we can do it on an indexing head or rotary table. And a lot of guys don't have that, so I'm going to shy away from using it. Although it's super easy once you figure out, 90, 90, 90. We can also do it with the digital readout on the milling machine here.
Now, the key to success here is to make sure that everything is clean and I have good lighting so I can see what I'm doing. I'm going to throw this V-block in here and the parallel that I made from a file a few years back. And then we're going to throw the part in here. Now, these studs here just have to be based off of the center hole, and they don't have to be exactly perfect for level on the face of that hub, because there's all kinds of science to it. But all I have to basically tell you is as long as these studs are perfectly drilled out from the inside there, it's going to be okay. Plus, this is just a lawn tractor, and you know, if it's a thou out, it's not going to be a big deal. Let's dial this in here. I wrote the kind of the directions here, north, east, west, south on there, just to give you an idea of where we're spinning. Now, for those guys that are new out there, basically I'm going to spin this around from one side to the other, say north or south, and if I zero it on south and move it over to north, and it moves 20 thou, I basically just moved the table in 10 thou. Sorry if that's a review for the more experienced guys. And if you do this enough times, you're going to get it dialed in, and it's going to look pretty much amazing like this. And the real key to success here is, is yes, to hit 0 on all of it so you don't lose your coordinates. So here's a little trick with your calipers, if you didn't know this already, is I'm going to measure the inside diameter of the hole, and then I'm going to measure across, and we're going to find how far apart these are on center. Now that I zero the calipers, magic happens, and we know that it's 4 inches on center between the holes. If you didn't know this already, you should give it a try on some different holes, and I think you'll be pretty surprised on this. Speaking of measurements, now we got to figure out what type of drill bit we need to drill these holes. Now, I've got a plate that actually, it was a really loose, rough plate that I'm kind of using as a guide here. It wasn't precise enough for us, but sometimes when I'm not sure of things and I made a mistake early in the day, I like just to lay the part over before I drill a hole to make sure I drill the hole in the right spot. Just in case my math is out or there's something out, it's good to double or triple check stuff. Now it's just a matter of going up 2 inches, down 2 inches, over 2 inches with the digital readout, and it's pretty easy once it's mapped out. And I don't know why I had it in my head, but when originally I started this project, I was just thinking, oh, just grab a 600 thou drill bit and drill a hole. Now I'm pretty sure there is a drill bit that exists for 600 thou, but it didn't exist in my shop. But I had the second best thing. Now, I had a drill bit that was, I don't know, 560 thou. I don't know what the fractional dimension is off the top of my head, but that worked out quite well. Because what I'm going to do is, I'm going to go around on my XY coordinates and drill all those holes to size. And then, spoiler alert, I'm going to grab the boring head and I'm going to bore these holes to the finished size. Now, because I only had to take off 20 thou on each side of the hole, total of 40 thou, to get my actual size, I could bore it in one size, as long as I did my setup the first time, and I did the first time correctly. And because of the screw up earlier in the day, don't worry, everything's getting triple checked, and we're making sure we don't make any more mistakes to put us behind time. So basically what I'm going to do here is I'm just going to kind of saw it up and down and nudge it towards it until it kind of leaves a little straight mark on the side. Probably not the best practice, could probably break the tool a bit, but this is working out quite well, and this is just how I do it. Now I'm just going to take a test cut, take a bit of material off, and then I'm going to go back in and I'm going to measure the size. After I've measured the size, it's pretty easy after that. I mean, the boring head's already got the dimensions on it of how far to move it out, and you just move it out how much you want to cut off, and just hope that you don't go oversize. So this boring head served me quite well over the years and given me a lot of years of service, and it's even seen a bit of abuse that has stood up quite well too. So I don't think we talked about tolerances here. Now, the tolerances for the stud to the center of the hub are super important, and we made sure we got that bang on. However, the tolerances for clearances for these studs is a little bit looser. As long as we make sure that we got all of our holes on center, if we're plus 2 thou or minus 1 thou, it's not overly that big of a deal. In fact, we could probably go a little bit further than that, so I'm not overly stressing about this here. As you saw earlier, I measured the stud, and we're going for close on it. However, if I go a little bit bigger on this hole, it's not a big deal, because remember, I have that quite large knurl there, and the purpose of the knurl is not only to locate it, but to stop that nut from spinning. And the knurl actually sticks up at least 20 thou or more, so that'll cut quite well into the hub.
Hey, I'm pretty sure you guys noticed I got this new Uber Flex light here. Thanks a lot for KBC for sending it out. I guess Dave kind of noticed I had that kind of junky one off to the side there, and I really never used it because it was either in the way or just wasn't quite bright enough. And man, this thing here, this is a game changer. This allows me to kind of get what I gotta see, do what I gotta do, and I really appreciate it, guys. All right, now let's get this out to the side shop. We'll broach this, we'll slide these in here, and we'll get this on the race cart. Okay, so out on the side shop here, we've got our Greenwood Arbor press. You guys have seen this one where I made the counterweight for it and the hand wheel. They're pretty cool videos. You should check them out. We also got our Dumont broach kit set here. And we're going to broach this Keyway. So there's almost something kind of therapeutical about broaching Keyways. And there's a kind of a peace and serenity to it. So long as you follow a few small little rules. And one of them is using an arbor press. An arbor press allows me to feel as I push this broach through there, and it can tell me if I'm getting hung up on something or something's going a little bit sideways. And also, I can slowly let off. You'll notice I don't go all the way through all in one shot because I'm letting it off and letting that top of the broach reset to vertical again. Also, I ran into a small little problem and I didn't have quite enough travel, so I had to use the little spacers to push it through the rest of the way. And we're going to have to send this through twice to get to the final dimension. Now, there's a little tabby that comes with the broaches that you just install. It's a shim, so to speak. And we're going to throw some oil on the back of that, and then we're going to broach it through in the exact same manner as we did before. I've had a lot of really good success with this Dumont broach set, and it gave me pretty much the full span of all of the stuff that I'm going to need for any project that's coming down the road. Although the upfront cost was a little bit high, it saved me and served me quite well over the last few years. Now, let's clean these parts up, put them back in the box, and have a look at this part. That worked out quite well. I mean, look at the beauty of that. Let's turn this daisy wheel around and press some of these studs in. Now, it's not exactly the ideal setup, but it is pretty much the only setup that I could come up with. Because if I pressed one stud in on the daisy wheel, I would only get one in before the studs would be banging into the daisy wheel, and I wouldn't be able to push any more in. So this turned out really well. Now, it's just a matter of jumping in the truck and heading over to Theron's and fitting this bad boy up. And if I don't say so myself, the fit is pretty darn amazing. Now, all the hard work's in Theron's hands, but the rest of the mods of lowering the tractor and putting a little bit more horsepower to it. That's going to get us out to the races and hopefully pulling in a few more wins, and most importantly, having a lot more fun. Hey, if you like this video, check out this other video I got here, and I know you're going to like it, and we'll catch you on the next one. Stay safe. Nifty for getting in down below. Whoa. Whoa. Stay on that color. I like that one.